Hi everyone, my presentation is about using semi-supervised learning for predicting financial literacy. The title includes of the two topics, financial literacy and semi-supervised learning. I think recently both of them are a hot topic. There are a lot of research works in the field of the financial literacy in different countries at the moment. I will try to explain about the concept of the financial literacy and how we can use it, and then I will talk about related works and literature review. After that, I will explain what's the challenges and contributions, and then I will try to explain the methodologies and experiments. There are some common definitions and factors involved for financial literacy. Some common definitions is the capability of taking responsibility in the management of the financial affairs, ability to take effective decisions about how to use and manage money. This type of the definition used a lot in the different literatures. I think a modern definition can be the ability to turn opportunities into wealth. The most common factors that affect the level of financial literacy are geographical location, educational level, income level, age, gender, demographics, ethnicity, language, and social factors. All these things play a key role in level of financial literacy. Who is financially literate? According to Lozardi and Julie's research, if you understand concept of the compound interest, inflation, time value, and money and risk diversification, it means you have an advanced level of financial literacy. For example, risk diversification. Risk diversification is the most challenging questions, and only 9% of the people could give a correct answer to this question in Australia. How to predict financial literacy of customers to identify risk and opportunities. For example, we can identify earlier those customers are suffering from lack of knowledge in financial literacy, so we can find who will be at the risk of decreased retirement preparedness, and then we can assign some specific financial consultancy program for them. The best place to get recorded financial activities is superannuation companies and bank databases. Our dataset is belong to CFS, and CFS is one of the superannuation company in Australia. How to enhance marketing dollar value by contributing in developing customer behavior analysis toward financial literacy problem. This question addressing how we can consider financial literacy variable into customer segmentation plan, or how we can improve grouping of the individuals that are similar in specific ways for marketing purposes. Most recent literatures did a study about definition and effect of the financial literacy. In some literatures, like Lozardi in 2010, they did online survey and asked volunteers 4 questions to determine the level of financial literacy. Also, there is a few papers use only supervised learning and labeled data for measuring financial literacy. As far as I know, there is no study using semi-supervised learning methods for FL problem. So this study can be an initial step towards using unlabeled data for FL problem. The online survey is not always proper way to measure the level of financial literacy. Sometimes other methods like using machine learning to analyze recorded data is more economical and constructive. The issue is most of these type of data in finance networks are unlabeled. So the best strategy to exploit these unlabeled data is using semi-supervised learning method. When collecting labeled data is expensive or is not accessible, in this case, using semi-supervised learning is the best approach. In semi-supervised learning, we try to find out some meaningful features from unlabeled dataset and use them in prediction model. This is main reason of using semi-supervised learning. Especially recently is a very popular approach because the amount of the unlabeled data increasing very fast. In fact, with SSL, you can get good result with less cost. Two main components of the SSL are SSR and SSC. In this research, I use SSR because the target variable is a real value. There are 2 different approaches in SSR, transductive and inductive. The transductive method is more popular because it utilizes all existing features in datasets. Challenges and contributions. Challenges. The effectiveness of a proposed SSL algorithms for regression task. It seems that the real value type of the target variable in regression task confronts a practical difficulty in the implementation of the SSR algorithms. A plethora of noisy data and imbalanced target variable, which leads to many quite false date estimated points. How to exploit a large amount of the unlabeled data in market to estimate financial literacy. Contributions. To analyze the effectiveness of the proposing non-parametric SSR with flexibility of meta-regression algorithms. Exploit over and under sampling techniques to deal with imbalanced target variable. To identify the statistical association on the key attributes in unlabeled data that affects on financial literacy. In this slide, we show the model process workflow in 4 steps. In input data, we use 25% labeled data. In pre-processing step, we apply data cleansing, feature selection, and sampling strategies. In labeled set data augmentation, we exploit semi-supervised regression, and in the output section, we do the model evaluation. Here we proposed SMOGN co-regressor semi-supervised learning model techniques for regression. We applied SMOGN techniques for pre-processing before the learning phase to improve model performance. The SMOGN regression technique combines undersampling the majority class and oversampling the minority class. So as our contribution in this work, we combine sampling strategies with a non-parametric multi-learner semi-supervised regression algorithms to improve prediction accuracy on unbalanced and unlabeled data input. This mixed methodology by the SMOGN co-regressors is work efficiently not only in our targeted dataset and even other similar financial data. In SMOGN, we set the threshold to 25% and Gaussian noise to 5% in maximum iteration 500. Also, here we use co-regression, which is a non-parametric multi-view and multiple learner SSR methods. Co-regressor exploit 2 k-nearest neighbor learners with different parameter setting like distance orders and p-value, so that one regressor can label unlabeled data for the other one. And the final prediction is the average of both regressor output. So we use a mechanism to estimate labeling confidence by measuring MSE metrics in each KNN regressor. We could enhance the initial labeled subset to 194% with a maximum of 500 iterations. Or we can say 64% of the unlabeled data used for the prediction task. This makes the model more reliable and reproducible. Here we compare our model with one baseline model and 5 widely used supervised regressors on FL dataset. We use 3 different evaluation metrics to ensure the effectiveness of our model performance. We can see the SSGR algorithm outperformed other supervised regressors and has better performance than the baseline model. In supervised algorithms, the gradient boost result is very close to the proposed model with 25% labeled dataset. This graph shows another interesting finding. This graph clearly emphasizes the importance of exploiting the SMOGN sampling technique to improve model performance on imbalanced datasets, and shows how these 2 algorithms are compatible. We can see here by adding SMOGN sampling to the self-training co-regression algorithm, we could get superior results in SSL. However, here M5 and random forest also show a more stable prediction output as well. This graph shows the uncertainty or sensitivity of the model output. We can consider this as a limitation. In fact, when the size of the unlabeled data or unlabeled ratio increase more than 70%, it has a negative impact on the model performance. In this study, we developed a novel method to predict the level of financial literacy of customers in an Australian superannuation fund by using their finance data. We got a superior result in our SSL method by exploiting unlabeled data, and also our algorithms could label 64% of the unlabeled data effectively and use them in the learning process.
When we have to use a large unlabeled data in prediction task, this method could improve the reliability and scalability of the method in the comparison with using only supervised learning algorithms.
This is end of my presentation. Thank you for listening.